in Driver's review part 11. Now we've got an interesting one here where we have y equals x to the natural log x. When you have a problem that looks like that, it's helpful to use logarithmic differentiation. With logarithmic differentiation, we're going to take the natural log of both sides. So I have the natural log of y equal to the natural log of x natural log x. Now the reason that that's helpful is now we can use laws of logarithms. We can move that exponent out in front. So we have the natural log of y is equal to the natural log of x multiplied by the natural log of x. On the left side, now we have implicit differentiation. So natural log of y, 1 over y dy dx. On the right side, we can think of this as product rule if we want. I think I will. First times derivative of the second plus the second times derivative of the first. So I've got 1 over y dy dx is equal to the natural log of x over x plus the natural log of x over x. So now I can kill off the y, multiplying the y to the other side. Cancels this out. We have dy dx is equal to, well, natural log x plus natural log x would be 2 natural log x over x. And now here's a tricky part. This says y equals. Notice the original problem said y equals. So we can replace that y with x to the natural log of x. In problem 10, they're asking us to take the derivative and plug in a 0. So let's go y prime is equal to derivative of the outside 2/3 to the negative 1/3. Don't change the inside. Multiply by the derivative of the inside, which is 2x minus 3. Well, at this point, let's plug in a 0 and see what happens. We have y prime of 0 is equal to 2/3 multiply by, if I plug in a 0 for my x's here, I get 1 to the negative 1/3 power. If I plug in my 0 over in the last term, I get a negative 3. Now, we need to realize that 1 to any power is going to be 1. So that part we don't even need to think about. We can cancel out the 3's. Don't forget this negative 1 though. And we get a negative 2. In problem 11, we have inverse sign and we have a chain rule with a fraction on the inside. So remember, the derivative of inverse sign is 1 over root 1 minus x squared. So dy dx is equal to the derivative of the outside, 1 over root 1 minus something squared. Don't change the inside, so bring down the 1/3 x. Multiply by the derivative of the inside, which is a 1/3. If we square this 1/3 x, we get 1/9 x squared. So dy dx is equal to 1 over square root of, now I'm going to write this as a common denominator. So notice my denominator is 9. So this 1 I'm going to turn into a 9 over 9. That allows me to write this as 9 minus x squared over 9 times my 1/3. Now, back in Algebra 2, we learned that if we have a fraction under a square root, we can break it apart. So now I've got 1 over root 9 minus x squared over root 9. Now, this 1/3, I'm going to go ahead and I'm going to write it as 1/3 so that you can see what's happening. Square root of 9 is 3, and now these two 3's cancel out. Final answer is 1 over root 9 minus x squared.